All right, today we are going to talk about determinants and then also inverse matrices. The determinant, each square matrix has a real number associated with it called its determinant. The determinant of a matrix is denoted by this, it's DETA, or sometimes we'll put these little bars, it kind of looks like absolute value bars, and then it's usually a capital letter inside, and that's also the determinant as well. And it's the difference of the products of the elements of the diagonals. So, what does a determinant of a 2 by 2 matrix look like here? It's just A times D, and then you're going to subtract off C times B. Okay, so that is it. If they put just these bars, it's asking for the determinant. Notice out here they put the word determinant. So just kind of be looking out for that. The big thing people kind of mess up here on this is they don't realize this is asking for the determinant right there. So make sure that you're looking out for that there. So pretty easy. By the way, this can only be on square matrices here. So that says that right there at the beginning. So you can't do the determinant of like a 2 by 3 matrix. So find the determinant of the following matrices here. So this is easier, 6 times negative 4. And just for our notes here, I'm going to write this out. 6 times negative 4. And then you're going to subtract off the other product of those right there, 1 times negative 2. So that'll be negative 24, and then that'll be minus negative 2, which will change that to a plus there, right? And then that combines up to negative 22. And that's the determinant. Okay. Now, what we use the determinant for, this number right here, it actually helps us with what we call inverse matrices, which is what we're going to talk about in the lesson tomorrow. Inverse matrices, we use those a lot to solve equations dealing with matrices. And you'll kind of see it a little bit more tomorrow, but we're going to use today to set it up. So, anyways, 2 by 2 matrices are pretty easy to find the determinants. To do a 3 by 3 matrix takes a little bit more action going on. So first thing you're going to do is you're going to take these first 2 rows and you're going to rewrite them again off here to the side. So I'm going to write 1, 4, 7, and then we're going to write 2, 5, 8. Okay, and the whole idea is you're going to take all of these numbers, these diagonals going down. You're going to multiply all those numbers together. So you're going to have 3 different total numbers, and then you're going to add that. And then afterwards, you're going to do the same exact thing, starting at 7, 5, 3, 8, 6, 1, 9, 4, 2. You're going to multiply all 3 of those diagonals together and then sum those, and then you take the difference between them. So that kind of sounds wordy. It's really not as bad as it looks here. So now I'm going to write the full workout. Normally, I'll skip this first step here. But so the first one here, we're going to go 1 times 5 times 9. Okay, and then we're going to add that to whatever 2 times 6 times 7. Okay, and then you're going to add that to 3 times 4 times 8. All right, so this is your first diagonal, second diagonal, third diagonal there, all in red. Okay, now usually the first step I write out here is actually doing all that multiplication in my head. So 1 times 5 is 5. 5 times 9 is 45. So normally I start out with 45. 2 times 6 is 12. And then 12 times 7 is going to be 84. And then what do we have here? 3 times 4 is 12. And then 12 times 8 is 96. Okay. And that is that whole first row. If you want to go ahead and add them up together, you can. I'm going to pull up my calculator here because I don't want to have to think. So 45 plus 84 plus 96 is 225. Now we're going to have to do the same exact thing with the blue diagonals, and then we're going to subtract off those blue diagonals. So once again, I'm going to write it out real long here. The blue diagonals start with that left one. It doesn't really matter which one you start with. That'll be 7 times 5 times 3. Then we're going to add that to 8 times 6 times 1. And then you're going to add that to 9 times 4 times 2. There you go. Okay, and then after that, like I was saying, I kind of write out that first step, 3 times or what do we got? 7 times 5, which is 35 times 3 is 105. And then 8 times 6 times 1, not too bad there, 48. And then 9 times 4, which is 36. So what was that, like 72, I think. And then add those up. 105 plus 48. Oh, whoops, I typed this in wrong. Plus 72 is 225. So actually, this one's kind of a weird one here. The determinant, once you subtract those, is actually 0 in this case. Which, sometimes it'll come out as 0, sometimes it'll come out as, like a number like 28 or something random. Now, like yesterday, a lot of things you can do in your calculator too. I think you're going to be expected to do a determinant for a 2x2 and a 3x3 matrix without a calculator, so you need to practice with that. But I also want to show you how you do it in your calculator. So we're going to go back here to the graphing calculator. I'm going to put this away here for a second just so we can see the graphing calculator. So first thing, like before, we need to hit second and then x raised to -1. That gets us to our matrix screen. All right, our matrix that we're going to deal with, that 3x3 matrix from that last problem. And to get to where you can change the matrices here, you got to go over here to edit. So we're going to scroll right. I'm going to edit this 2x3 matrix I had in before. We've got to change it to a 3x3. And then we're going to type in our numbers here. Top row was 1, 2, 3. Oh, it's just 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we did our matrix right there, and then we're going to hit second mode to back out of that screen. And then to get the determinant, you're going to hit second matrix. You're going to go to this middle option here, and it's going to have a bunch of different things here. Really, I don't think we use anything else except really the determinant. I guess you could find the dimensions of your matrix if you wanted, but we'll go determinant, and then we have to enter in matrix A. So I'll hit second matrix again, and then I'll choose matrix A, and then enter. And notice that came out to 0. That was the same exact thing that we got when we were working it out. So that's how you can find the determinant of any matrix. It's pretty helpful on those 3x3s. Honestly, I think the 2x2s, they're so quick and easy that it takes more time to type it into the calculator. So I don't think it's that beneficial to use a calculator there. But anyways, there you go. Let's see if we can do another determinant by hand here. So we will kick off with that. So once again, you're going to write out those first 2 columns right there again. So 4, 1, 2. -2, 1, 5. Okay, and then we'll color code again. So we'll go 4 times 1 times 3, -2, -2, +2, and then 0 times 1 times 5. All right, so this first diagonal here, I'm going to do 4, 1, 3. That's going to be 4 times 1, which is 4, and then 4 times 3, which is going to be 12. So that's your first diagonal. Here, let's do this instead so y'all can keep track. Okay, so -2 times -2 times +2 there. That should add up to 8, or multiply to 8, I guess I should say. 0 times anything, that's super nice when they give that to you, because that means that's 0. Now let's do all the positive slopes. 2 times 1 times 0 is going to be 2. Or I'm sorry, 0. Anything times 0 is 0. You got 5 times -2 times 4. So what was that? -10, and then -10 times 4 is -40. And then 3 times 1 times -2, so that is -6. And then, yeah, that's good to go there. 12 plus 8 over here is going to get us 20, so we need to do 20 minus, I guess, -46. Which, remember, minus negative changes that to plus 46, so that'll be 66 right there for the determinant. Okay. So one of the applications of determinants here, if you have a triangle with 3 vertices and they're like all like on a grid, like maybe on a map or something like that with latitude and longitude lines, or if you just had it on a normal Cartesian plane, like an XY axis type of thing, you can use determinants to actually help you solve for the area. So instead of doing your typical base times height divided by 2, maybe you got some weird sides that aren't perpendicular, you can use all this stuff here, which can really speed you up there. So first thing, notice here that your 3 vertices of the triangles here, notice it's x1, y1, x2, y2, and then x3, y3. And then notice here we're putting 1s for that last column right there. And then remember, if they just put these lines here, that means we actually need to find the determinant. So if you want to write yourself a little note here, this means find the determinant of that 3 by 3 matrix. Then we're going to multiply by 1/2 right there. It's kind of like the half, times base times height. That's the half part right there. And then the plus minus symbol indicates that the appropriate sign should be chosen to yield a positive value. Sometimes when you get these determinants, or depending on like what order you put the order pairs in, sometimes you'll get a positive number, sometimes you'll get a negative number. So that's just saying change it to a positive number because you can't have a negative area. So let's do this here. Find the area of the triangle with these points right here. So first point is 1 or 10, 20. So I'm just going to write 10, 20, and then you put a 1 for the last column spot. All right, -8, 5, 1, and then -4, -5, 1. And then we're going to do the determinant of that. Remember, if you're doing the determinant, go ahead and add on that extra row or that extra column. So, it's not one to write here. 25, -5. Okay, let's do purple here. So all the slopes going down. 10 times 5 times 1 should be 50. 20 times 1 times -4 should be -80. And then 1 times -8 times 5, that should be positive 40 there. Negative times a negative. Okay, and then we're going to subtract off, get the other direction going here, the positive slopes. So it's 4, 5, and 1, so -4, so that should be -20 right there. -5, 1, and 10, so that should be -50. And then 1, -8, and 20, so that should be -160. Okay. And then after that, let's combine our like terms. 50, what is that going to be? 10 right here for this first one. And then -20, -50, and then -160. So I think that's that -70. And then so I think that's -230 if I did my mental math right there. And then minus a negative changes it to positive, so that's 240 right there. So that's the determinant. That's actually not the area, because remember, you need to do. So yeah, let's write this. The determinant was 240. So remember, the formula said do 1/2 the determinant there. So now I'm going to go 1/2 240. And then if it's negative, change it to a positive. So that should get us, I guess, 120 right there. And that would be the area. And then let's see, did they give us units? They did not, so we'll just say 120, and then I guess units squared. Right there, and that is it right there. Once again, you can do all of your determinant stuff using graphing calculator if you have that. So I definitely take advantage of that if they give that on a calculator section there. Okay, so the next big thing here, we're going to talk about inverse matrices here. So the symbol for an inverse matrix right here is the matrix raised to -1. Two matrices are inverses of each other if, when you multiply, the product is this thing called the identity matrix right here, which it is 1, 0, and then 0, 1. So basically, going from the top left corner down to the bottom right corner should all be 1s, and then everything else should be 0s right here. And we call this the identity matrix. And then since we can't really divide matrices, or matrices, I guess I should say, the inverse matrix, when you multiply them, that's kind of like how we undo it. Like you have multiplication and division with normal integers. Well, with matrices, you have to use the matrix and then the inverse matrix, and those will undo each other. Okay, so to find an inverse matrix here, if you have a square matrix right here, you got to go and you got to take the determinant right here. So actually the way I like to write this is it's 1 over the determinant, and then notice that the matrix is kind of switched around here. And I'll highlight a couple of the things, but it's 1 over the determinant. That's the determinant right there. Notice here that A and D were swapped, so you change those places right there. And then notice that the signs here for B and C, your original B and C, you just change your signs right there. And that gets us the inverse matrix. All right, and then tomorrow we're going to use those inverse matrices to solve systems of equations, which is going to be really, really helpful. It's going to speed it up a lot, but let's get the inverse matrices here going. So first of all, we need to find the determinant. I'm going to find that first. Usually I think we're going to just do 2 by 2s with these, so that's pretty nice. So 5 times 1 is 5, and then we're going to subtract off 2 times 3, which was 6. So that'll equal to -1. So the little formula for the determinant said 1 over the determinant, so 1 over -1. And then we're going to multiply that, some scalar multiplication. You switch the top left and top left and bottom right, so you're going to put 1 and then 5, and then you switch the signs of the 3 and the 2 right there. And if we multiply that right there, we should be able to get our inverse matrix. Now 1 over -1, you can change that to -1 if you want out front. Sometimes you're going to get fractions. Then you're going to distribute that to everything. So -1, +3, +2, and then -5 for your inverse matrix. Okay, and that is how you get your inverse. And we'll notate it with this right here. So we'll say A inverse is that matrix. Now, just like before, everything we're doing here, you can do in your graphing calculator. So I want to show you how to get the inverse matrix using your graphing calculator. So that was a 2 by 2 matrix. So I'm going to hit second matrix. I'm going to change matrix A to a 2 by 2. So enter 2 by 2. And then what was it? It was 5, 3, 2, and 1. Okay. And then pretty easy to do inverse matrices here. You're going to hit second mode to back out of that screen. You're going to hit second x raised to -1 or the matrix option. And then you're going to choose matrix A. And then you're actually going to hit that x raised to -1 button right there. And then if you hit enter, that should come out to the same matrix that we just got, which is exactly the same right here. So let's see here, air server. Just show you, that's the same exact thing we just got right there. Now, like I was saying, if you take your inverse matrix and you multiply that by your regular matrix, those should undo each other and you should get that identity matrix. I'm going to show you that real quick. So if we go hit second matrix, we're going to choose matrix A, and then we're going to multiply that by the inverse matrix. So I'm going to hit second matrix, and then I'm going to choose the A again, but then I'm going to add that inverse part, the second. Or actually, you don't hit second, you just hit raised to -1. And notice that comes out to the identity matrix. So what that essentially means is those two matrices undo each other there. Okay, so that is that. And let's do a couple more inverse matrices here to see what's going on. So this one here, first find the determinant. So you got 2 times 7, which is going to be 14. And then minus 0 right there, which actually just comes out to 14. So this one's going to be kind of funky here because we got this weird fraction 1 over 14. Okay, so we're going to go 1/14. Remember, switch the 2 and the 7, and then change the signs in the -5 and the 0. And then there you go. And then now distribute 1/14 to everything. So 1/14 times 7 would be 7 over 14, which would be 1/2. I'm just going to go ahead and write 1/2 right there. 1/14 times 5 is just going to be 5 over 14 right there, and that doesn't reduce. 0 times anything is nice because that's 0. And then 2 times 1/14 would be 2 over 14, which reduces to 1/7. So put 1/7 right there, and then we're good to go. So sometimes these are not going to come out very clean. Okay, let's see what's going on here with this last one. So you're going to have 6 times 3. Oops. Let's just write it like this. 6 times 3 is negative 18. And then we're going to subtract off. And then we got 2 times negative 9, which is negative 18. Which that's going to change to a plus here. So that's actually going to get us 0. Now this one's kind of weird. So the determinant is 0. And if we use a little bit of logic here, if you have 1 over 0 times a matrix, you can't really do 1 over 0. 1 over 0 doesn't make any sense. That's not really a number right there. It's kind of like an undefined thing we have here. So if you have all of that, you can't really distribute 1 over 0. So what that means here is there is no inverse with this case. There would be no matrix that could undo this if there's like matrix multiplication happening there. So that's no inverse. And if you want to write yourself a note why, you can say that's because the determinant was equal to 0 right there. So I want to put a star next to that. I don't know if that comes up on a test or quiz. That's a terrible looking star. My stylus is starting to not work here very well, but yeah, that's that there. I don't know. Yeah, I guess it didn't say anything here, so we do need to add this, that the determinant cannot equal 0. That's kind of important there for your inverse matrices. So, and use your answer in example 1 to prove that they are inverses. Multiply the matrices together. We did that with our calculators. If you want to do it by hand, you can. We'll probably skip that here for today, and that looks like that is it.